Math 1108, section 11.1 on the distance formula and equations of circles. We'll review the Pythagorean theorem first. That's the theorem that applies to right triangles. So if you have a right triangle, and if the length of the hypotenuse is C, and the lengths of the two legs are A and B, then the Pythagorean theorem says if you square the length of the hypotenuse, that's equal to the sum of the squares of the lengths of the two legs. Okay, so we're going to use the Pythagorean theorem to find the distance between 2 points in the xy plane. So I'll draw a picture of the xy plane, and we'll plot the points 2, 1 and 5, 3. Okay, the ordered pair 2, 1 is right here, and the ordered pair 5, 3 is right here about. And we want to find the distance between those 2 points. So we can construct a right triangle. We connect the 2 points with a straight line segment, and then we also connect horizontal and vertical line segments to form a right triangle. And the hypotenuse of this is the distance between the 2 points. So I'll label it D for distance. And then we can find the lengths of the horizontal and vertical sides of this right triangle. So on this one, the length of this side is 5 minus 2, or 3. And then the length of the vertical side is the y-coordinate 3 minus the y-coordinate 1. 3 minus 1 is 2. And then we can say, well, the hypotenuse squared, or the length of the hypotenuse squared, is equal to the sum of the squares of the lengths of the two legs. And then we'll do a little bit of arithmetic. 3 to the second is 9, 2 to the second is 4, and 9 plus 4 is 13. So the distance, we just take the positive square root. The distance is equal to the principal square root of 13. So that is the distance between those 2 points. Okay, using the same idea, we'll derive a distance formula. So if we have any 2 points in the xy plane, we'll call them x1, y1, and x2, y2. And we'll apply the Pythagorean theorem to derive this distance formula. Okay, so we'll just use a sketch just to represent what we're trying to do. So I'll pick one point and label it x1, y1, and another point, I'll label that x2, y2. And just like we did in the example above, we're going to construct a right triangle. We want to find the distance between these 2 points. So we'll connect those 2 points with a straight line segment. Then we'll connect horizontal and vertical line segments extending from the 2 points x1, y1 and x2, y2, and we form a right triangle. So let's label the hypotenuse D. D represents the distance between those 2 points. And then, since we're not using actual numbers, we're just using letters that represent numbers, it might be a little more challenging to write down what the length of this horizontal side is. Okay, but this is parallel to the x-axis, and the x-coordinate of this point is x1. The x-coordinate of that point is x2. And so the distance from x1 to x2 is the same as the length of this horizontal side of the triangle. So we can write it as, we'll use absolute values and write it as x2 minus x1. If x2 is greater than x1, then that length is just x2 minus x1. But this is just a diagram to help us, so we want to make sure that this length is positive. Okay, we'll do the same sort of thing to find the length of this vertical side. The y-coordinate of this point is y1, and the y-coordinate of that point is y2. So the distance from y1 to y2 on the y-axis is the same as the length of this vertical side of a right triangle. And so we'll just write it as the absolute value of y2 minus y1. Okay, then we're going to apply the Pythagorean theorem to this right triangle. So we square the length of the hypotenuse, that's d squared. And then when we square the quantity, the absolute value of x2 minus x1, we don't need the absolute value symbols anymore because we're just squaring a number, which will make it positive. So in parentheses, I'll put x2 minus x1, quantity squared, and then we're adding it to the square of this side of the right triangle, which is y2 minus y1 squared. This is just an application of the Pythagorean theorem. And so to find the distance between those points, x1, y1, and x2, y2, we just take the principal square root, or the positive square root of the right-hand side. The distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. And this is called the distance formula. So we succeeded in deriving the distance formula by using the Pythagorean theorem. Okay, now we'll apply the distance formula to find the distance between pairs of points. Okay, we're going to use the distance formula to find the distance between each pair of points. And it doesn't matter which point you label x1, y1, and which one you label x2, y2. But for convenience, I'll just write down the distance formula here. The distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so I'll pick 5, 7 to be the x1, y1, and I'll pick 2, 3 to be x2, y2. I can do it either way, it's okay. So the distance is the square root. Okay, so x2 minus x1 quantity squared, or 2 minus 5 squared, and then plus 3 minus 7 quantity squared. And then we'll just do the arithmetic on the inside of the square root. Okay, 2 minus 5 is negative 3, so we get the number negative 3 squared. And then plus 3 minus 7 is negative 4, so it's negative 4 squared. And then we get the distance is equal to the square root of some number. Negative 3 squared is 9. The number negative 4 squared is 16. And then finally, the square root of 9 plus 16 is the square root of 25. And the square root of 25 simplifies to 5. Okay, so the distance between those 2 points is 5. Alternatively, if you want to plot those 2 points in the xy plane, construct a right triangle, and then apply the Pythagorean theorem directly, you can do that. Using the distance formula is nice, but it's not the only way to do it. Okay, so let's look at the next example. Find the distance between the points negative 3, 5 and 4, negative 9. Okay, so we have the distance formula up here to look at. So I'll pick the negative 3, 5 to be the x1, y1. And I'll pick 4, negative 9 to be the x2, y2. You can do it in either order, it doesn't matter. So the distance formula, the distance is equal to the square root of, okay, so x2 minus x1 is 4 minus negative 3, quantity squared, and then plus y2 minus y1, so it's negative 9 minus 5, quantity squared. So as usual, you have to make sure you're careful whenever you're dealing with negative numbers. Okay, so we'll get the distance equals the square root. Okay, so arithmetic, 4 minus negative 3 is the same as 4 plus 3. And 4 plus 3 is 7, so we get 7 squared. And then negative 9 minus 5 is negative 14. And so we'll get negative 14 squared. And then 7 squared is 49. And negative 14 squared is 196. And then when we add those two numbers, we get the square root of 245. So we'll leave it in this form right now. You can work on simplifying that if you can. But let's get to a couple of other examples. Find the distance between negative 8, negative 2, and negative 1, 6. Okay, so the distance is equal to the square root. So this time I'll write negative 8 minus negative 1, quantity squared, plus negative 2 minus 6, quantity squared, the square root of that. And then we'll do the arithmetic. So in this one, negative 8 minus negative 1 is negative 8 plus 1, so that's negative 7 squared. And then plus negative 2 minus 6 is negative 8, so we get negative 8 squared. Negative 7 squared is 49, and we're adding that to the number negative 8 squared, which is 64. And this time we get the square root of 113. Okay, one more example. So the distance is equal to, let's write 6 minus negative 2 squared plus 4 minus negative 7 squared. And we get 6 minus negative 2 squared, that's going to be 64, and then plus 4 minus negative 7, that's 11 squared, or 121.